Let us consider the another problem to solve by the saddle point method of the pure strategies game. Solve the following game whose payoff matrix is given by, this is the payoff matrix is given here. Player B, course of actions is the 5 and player A, course of actions is the 4. So first we have to find out the row minimum, each and row minimum each and every from the row minimum, then we have to find out the maximum of that. And column wise we have to find out the maximum, maximum and maximum, maximum. If they are same, then we say that it is the strictly determined, so that the game is strictly determinable, yes or no. If they are the same, then we say that the following game is strictly determinable. Solution. If anything is not given, normally we are saying the player A is the maximizing player and player B is the minimizing player. Let A be the maximizing player and B be the minimizing player. Now we find the minimum of the row and maximum of the column. So after that we will get the maximum of the minima is 4 and minimum of the maximum is 4. So since the maximum and minimax is the same, so we can say that exists the saddle point and the problem is strictly determinable. So this is our the saddle point. What is the saddle point? A2, B3 position is our the saddle point, and what are the value is there? That is the value of the game. Therefore, we get maxi minimum is the V lower bar is equal to maximum of 0, 4, 2, 1 is equal to 4, and minimum of the maximum is equal to V upper bar is equal to minimum of 9, 6, 4, 8, 8 is equal to 4. So you can write maximum is equal to 4 is equal to minimax. That is the V lower bar is equal to 4 is equal to V upper bar, or we can say, so since the maximum and minimax is equal to 4, so we can say the game is strictly determinable. And saddle point is the position of the 4, that is A2, B3, and value of the game is V lower bar is equal to V upper bar is equal to 4. Now we move to the game theory part where the saddle point does not exist. Then how to solve it in this case? That is it is not the pure strategy problem, it is the mixed strategy problem. This is already we seen, but we need this payoff matrix for discussing the next topics. That's why I am keeping here. I have to check it once. It's a payoff function. What is called the payoff function? Let Aij be any payoff matrix of the order m cross n. This is that we are considering is a payoff matrix of the order m cross n, and Aij is our the general element where I is equal to 1 to m and j is equal to 1 to m. Then the payoff function, or we can call the mathematical expectation of a game, which is denoted by EPQ. E is the notation of the expectation, mathematical expectation related to your probability. So defined as, now the expectation function we are defined as expectation of PQ. That means there is the two thing at a time. That's why double summation is there. For one is the one summation, another is the another summation. That's why the double summation. We are taking the product of that. That means if I take P1, P2, P3, Pm be the probability of selecting the strategies 1, 2, I to M for the player A. That is the probability. So Pi is the probability of selecting the ith strategy. So summation of Pi is equal to 1, and Q1, Q2 up to Qn is the selecting the strategy 1, 2 up to n is respectively the probabilities. Or we can say Qj is the probability of selecting the jth strategy. So summation Qj, j is equal to 1 to n is equal to 1. Now we are taking the expectation. That means if I take the expectation with respect to, that means the general term I am considering. So Pi, Aij into Pi into Pj. Now you have to take the summation. One way is I summation and one way is the j summation. That's why the double summation is there. That's why expectation of PQ is equal to I is equal to 1 to M, J is equal to 1 to N, Aij, Pi, Qj, where PQ are the mixed strategies for A and B respectively. In particular, if B takes is the pure jth move only, then the expected gain of A is given by. Only we are considering when the B takes is the pure jth move. That means if I take B selecting only the jth strategy, then what would be the expected gain of A? This is multiplied by P1, this is multiplied by P2, this is multiplied by Pi, this is multiplied by Pn, and taking the summation of this, we will get the expected gain of A when B selecting the jth action of the course. When player B is selecting the jth action of the course, then what would be the gain of the player A? Probability of 1, that means P1 into A1j, probability A2j into probability 2 P2. So Aij into probability of selecting the ith strategy by the player A is the Pi, and Amj into Pm. So expectation of jth P is equal to I is equal to 1 to M Aij Pi. Aij is the intersection of the element of the ith row and the jth column. Jth column selected by the players B, and Ai is the general term Aij into Pi, I is equal to 1 to M. So this is the expected return of the gain of the player A. Similarly, for the particular ith pure move of A only, then the expected loss of B is given by EIQ is equal to J is equal to 1 to N, Aij, Qj is equal to 1 to M. For each and every row, we will get this structure. Games without saddle point. We have seen that there are games having no saddle point. In such game, the principle of saddle point solution, maximin and minimax, breaks down, and the player do not have a single based plan as that the base strategy. Each player can improve his payout by selecting a different strategy. The game in this case is said to be unstable. In such case, each player has to take recourse to some mixed strategy in order to maximize his gain or to minimize his loss. That means player A can change his selecting the strategies from 1 to 2, 2 to 3, or randomly selecting that to improve his gain. At the same time, player B also selecting their strategy by changing from 1 to 1 to minimize his loss. So they can not fixing for a particular strategy. It is the continuation of that. Each player would like to play in a random manner so that his final payoff over a large number of plays of his game will be optimal. It may so happen that he may lose more in any individual play of the game if they are doing to trial and error method, choosing the 1 to 1, 1 to 1, and A is selecting the 1 to M, B is selecting 1 to N. So many combinations is there. So we will get the so many combinations, the individual play of the game, but the overall effect will be optimal for him. The simplest way to mix the individual strategies in a random manner is to take the recourse to chance mechanism by introducing the probabilities with the choice and mathematical expectation with payoff. So if we try to do that by selecting one by one, so that is the complex and complicated to selecting the optimal or finding the optimal strategy. So in this case, we are trying to solve with the help of the probabilistic method, that is by calculating the mathematical expectation with the help of the payoff matrix. Now in this case, we are considering simple 2 cross 2. So optimal strategies and the value of the game, solution of a 2 cross 2 game, mixed strategies. Now we try to solve a mixed strategies problem, that is player B is not selecting for a particular strategy and player A also not selecting a particular. So A can choose A1 or A2, B can choose B1, B2. So any combinations is there. From that we are calculating our strategy of the player A and strategy of the player B. It may be the combination of these two, it may be combination or not one, because it is a mixed strategy. That's why it is combination of that. Maybe B selecting the one, but A cannot be selecting one. In this case, A should be selecting the both. But if A is selecting the one, B should selecting the both. If they are selecting one, so it will be the pure strategy problem. But here it is the mixed strategy one. Let us consider the P of matrix for A is that this is player A, strategy is A1, A2. For the player B, strategy is B1, B2. And this is our the payoff matrix, A11, A12, A21, A22. So let the problem has no saddle point. In the case of the pure strategy, in the payoff matrix for A. So we solve the problem by using the mixed strategy. And let P1 and P2 be the probability for selecting the strategy A1 and A2 for the player A. And let Q1 and Q2 be the strategy, be the probability selecting the strategy or the course of action B1 and B2 for the player B respectively. We are writing in this way. P is the P1 and P2, that is the probability of selecting the strategy A1 and A2 for the player A, and Q is equal to P1, Q2. That means player B selecting their strategy B1 and B2 with the probability Q1 and Q2 respectively. Where since this is the probability of selecting A1 and A2, so P1 plus P2 is equal to 1 and P1, P2 greater than 0. Similarly, Q1 plus Q2, Q1 plus Q2 equal to 1 and Q1, Q2 greater than 0 for A and B respectively. Now the problem can be solved algebraically as by finding the expectation when the player B choosing the course of action B1. Similarly, where course of action B2, and also when A selecting the course of actions A1 and A2. So we will get the 4 equation, and from that, by taking the optimality conditions, that the equilibrium position, we try to find out our optimal strategy and the value of the game. Now expectation E1 of P, that is probability of expectation E1, we are writing as player B selecting the course of action B1. The net expected gain for the player A should be E1. We already learned in the payoff function. E1P is equal to A11P1 because it is selecting the 1. So it would be C. When player B is selecting this, so P A11P1, A21P1, P2, A11P1, A21P2. But P1 plus P2 is equal to 1. So instead of P2, we can write 1 minus P1. So A11P1 plus A21P2 equal to A11P1, and P2 we can write 1 minus P1, A21 into 1 minus P1. Similarly, B is pure move to B2. Then the net expected gain of the A is given by E2P equal to A12. That means the second column we are considering, second column element. A12 multiplied by P1 and A22 multiplied by P2, and P2 replaced by 1 minus P1. Now, we try to find out the loss of B. If B plays is the mixed strategy, Q equal to Q1, Q2 with Q1 plus Q2 is equal to 1, and if A plays A1, then the B's net expected loss will be, when A is selecting the A1, what would be the net loss? So we are multiplying the column wise, A11, A12 multiplied by Q1 and Q2. So expectation of Q1 means when A is selecting the strategy 1, A11 Q1, A12 Q2. Q2 will be replaced by 1 minus Q1. And it A plays A2, then B's net expected loss will be expectation of Q when the A choosing the strategy 2, A21 Q1 plus A22 Q2 is equal to A12 Q1 plus A22 1 minus Q1. Now, if V be the value of the game, then expectation of 1P greater than equal to V and expectation of P greater than equal to V and expectation of Q less than equal to V and expectation to Q less than equal to V. So expected gain is greater than equal to V, value of the game, and expected loss is less than value of the game. So both are tried to minimize and it is maximized in the equilibrium position or in the optimum situation, both will be the same. That means expectation 1P, that means when B choosing the action of 1, course of action 1, strategy 1, and player B selecting the course of action 2, or we can say the strategy 2, then we say strategy 2, then we say it is the E2P. So both will be the same. Similarly, we can say E1Q is equal to V is equal to E2Q. So V is the value of the game. So equating this E1P equal to E2P and E1Q and E1Q is equal to E2Q, we will get a relational relation. So from this considering, we will get A11P1 plus A21 1 minus P1 is equal to A12P1 plus A22 1 minus P1. By changing the side, we will get, if we take, this is one side, so here we left A22 minus A21 in the right hand side, and this is, we can take this side. So these two terms and these two terms with the P1, this, and this term and this term is free from P1. So this is in the right hand side, and left hand side we will get P1 into A11 plus this is changing the side, it will be the A22. So A11 plus A22, and this is A21 is minus, and when it is right side to the left hand side, it will be negative. So it is combining in the one term, A12 plus A21. So this is our the denominator, and numerator is A22 minus A21. So after solving this, we will get P1, and P2 will get this, but better, as soon as we got the P1, we can easily find out P2, because P2 is equal to 1 minus P1. But otherwise, we can put here P1, and from that we will get the P2. But during the numerical calculation, it is better if we put the value of P1 here, and we will get the value of P2 equal to 1 minus P1. Which are the optimal strategies for A? That is, P1 is the probability and P2 is the probability of selecting the strategy 1 and selecting the strategy 2. Similar way, we will get Q1 equal to A22 minus A12, A11 plus A22 minus A12 plus A21. Denominator is the fixed, and Q2 is equal to this, but we know Q1 plus Q2 is equal to 1, so Q2 is equal to 1 minus Q1. From that we will get the value of Q2. If we put the value of P1, P2 or Q1, Q2 in the any relation, then we will get, if we put any relation, so this is equal to expectation of P1, so this is equal to is our the V. We can put anywhere, we will get the value of V. From that, this is the denominator is the fixed, and numerator is the basically the value of the determinant of the payoff matrix. This is the value of the determinant A11, A22 minus A21, A12. This is the value of the determinant of the payoff of the matrix. And to remember this, it is easy. A11 plus A22, whatever the product is there, we can take it A11 plus A22. And here A21 plus A12 with the plus sign is the denominator, and this is the value of the determinant. And how to remember the formula? See, when we are finding the P1, so block it, A22 minus A21 divided by A22 plus A11 plus A22 minus of combining this A21 plus A12, or we can write A12 plus A22. P1 and P2 will get 1 minus P1. Similarly, for Q1, block it A22 minus A12, and denominator is the same. And for the value of the game, V equal to value of the determinant is A11 A22 minus A21 A12 divided by, that is the denominator, A11 plus A22 minus A21 plus A12. Now one definition is there, what is called the fair game. If the value of the game is 0, that means no one getting and no one losing. So there is no gain, no loss. Then it is known as the fair game. If the value of the game is 0, that is there is no loss, no gain for any player, the game is known as the fair game. So with the help of this formula, we try to solve the mixed strategy problem in the next class.